All right, still chapter 8, section 4. We've been talking about trig ratios. Remember, trig ratio is a ratio of sides that matches up with an angle, an acute angle for any right triangle. So ratio of sides matches up with a certain acute angle. We've said in the past that angle measure is not the exact same. Like if I got a 4-inch side, I don't have a 4-degree angle. But if I can do the ratio of sides in right triangles only, it'll match up with an acute angle measure that kind of coincide with each other. So recall, sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. Tangent is equal to opposite over adjacent. So, as we're doing this, we found the sides already in the last assignment. What happens if we need to find an angle? That's what we want to talk about today. So, I also want this triangle. Put this in your notes. SOH. Division, division times. CAH. Division, division times. TOA. Division, division times. This is going to help you set up problems. It's a shortcut. And once you pick it up, it should be easy and tell you what to do. Obviously, we're going to be using calculators too. The acronym for our trig ratios is SOHCAHTOA. SOH, CAHTOA. SOHCAHTOA. Just so happens that was the name of the Indian leader for the Kapaktak tribe. Now you know where it all fits into play. It's all about the triangles. So Chief SOHCAHTOA and the Kapaktak tribe made some seriously great triangular teepees. So let's look here a little bit. If you want to find an angle, so there's some notation we need to be here. We've been finding side lengths. Knowing an angle, missing side, we had to find side lengths. If you want to find an angle, we're going to do inverse sine, which looks like this, notation-wise. So you have a -1 exponent with it. Inverse cosine, -1, and of course inverse tangent. And that will be tangent -1. Those are used to find angles. So I'm going to use that to find angles, but I'm going to go back to the triangles and show you how they work. Pretty easy for us, and then we'll apply it here when we try to find angles. So in this example, I can't remember if I put it on there before or not, but let's do this. Got to find the side. Here's 18. Here's a 25-degree angle. All right, so reference angle. What is this to it? This will be adjacent, touching. What is this to it? Opposite. It's not touching it. This is always a hypotenuse, doesn't matter. So opposite and adjacent means it's tangent. So we learned this. I'm going to take the tangent of 25 equals opposite over adjacent. We put it over 1 and we solve the ratio. Here's how the triangle works. For the triangle, for the SOHCAHTOA triangle, you will cover up what you're trying to find and it will tell you what you need to do. Example, I want to find opposite, so I cover it up. It says take tangent of the angle times adjacent side. Well, think about it. Isn't that what we were doing there? So some people say, oh, no big deal. It'll really pay off here in a second for you. So I hit my calculator. I want the tangent of the angle. So I'm going to hit tangent 25, close my parenthesis, please, times 18. Use the calculator. Approximately 8.39. Done. What if, another example, using the triangle now. So there I was just trying to find the top part of it. What if, let's just go like this. Let's go 5, let's go 3, and I don't know, let's say we got okay. So I got this, let's just say 60-degree angle, just, I don't know why. Reference angle. So now look, opposite, hypotenuse. So this has to be sine. So the sine of my 60-degree angle equals I wanted an x there, sorry. X over 5. Same deal, using my trig functions. I go up to here, I go to sine. What am I trying to find? Opposite. Cover it up. What's it tell me? Sine of the angle times hypotenuse. So, I hit sine of 60. Excuse me. Times 5. Approximately 4.3. All right, final example for the triangle in terms of finding sides. This time, let's go here. 37-degree angle. Let's go, I don't know, 6. Let's try to find hypotenuse. Let's see better if I do that. 37-degree angle. Hypotenuse is missing. Adjacent side. So, reference angle. Adjacent, hypotenuse, cosine. So cosine of 37 equals adjacent over hypotenuse. So, draw my little triangle here so I don't have to keep moving my overhead. So I cover up what I'm trying to find. That would be this. This says take adjacent side divided by the cosine of the angle. I mean, we could go through and do all this. That's going to give me 6. That's going to give me cosine of 37 times x. But then I got to divide by the cosine of 37 on both sides. Why am I leaving it like this? Because the decimal doesn't end, doesn't repeat. So look how this lightens up the load for you. Cover up. It tells you what to do. Right there. Saves you steps. So I want to take 6 divided by the cosine of 37. So 6, clear. So 6 divided by cosine 37. Good practice. Close it. Boom. Using the triangle. Okay, so now, how's the triangle going to help us? Really helps us when we're trying to find angles. So let's say angle B, angle C, angle A. I'm going to give you 27 here, 18 here. Directions. Find the measure of angle A. So if I'm finding angles, that means I have to use inverses. Calculators, so important with this. So I'm using inverses. Well, first of all, reference angle is A. So if A is my reference angle, I then Let's understand what I have. Hypotenuse, opposite. What trig function is that? Sine. So I'm doing the sine, but since I'm finding the angle, I'm doing the inverse sine of 18/27. Okay, so here's what this looks like. I'm going to hit my second sine. And then I will plug in, I want this fraction though. I want 18 divided by 27. I got to have that close. Because whatever this ratio is, well, the ratios don't always come out nicely for us. So as I do this problem, I hit second sine. So I see the notation up there already. And I want 18 divided by 27. So approximately 41.8 degrees. That's our angle. So 41 degrees, round to the nearest. Ouch. 42 degrees. We round to the nearest angle. Now, how can the triangle work for me on this? Look. Sine, opposite, hypotenuse, divide, divide. There. So, plug in what we know. Don't know this, so there's where x is. Equals opposite 18/27. So I have to do the inverse sine when I'm finding angles. When you find an angle, there's your process. Now somebody will say, well, what if I wanted to do this angle? Well, what if B was your reference angle? Well, let's think for a second. This is 90. This is 42. What should this be? Without even thinking. Should be 48. So that's how you figure it out, if I know one already. But let's prove it to you just to make sure. So this would be my reference angle. So angle B. So adjacent hypotenuse, so that's a cosine problem. Cosine -1 of angle B, sometimes you'll see the angles in there, equals 18/20 adjacent over hypotenuse. So what's it tell me to do? I want the angle that matches up with this ratio. So let's see what we do. Clear it. Second, cosine 18 divided by 27. Close it. 48.1. .48 degrees. Rounding works out for us. Try one more example. This time I want you to find the angle again. And this time the angle will, or the triangle will look like this. Yeah, let's do this. All right, last example. I need you to do this. 15, right angle, 36, 39, call this M, call that N. I need you to find measure of angle M and measure of angle N. Go ahead, pause it, figure it out, see what you come up with. For me, the solution is depending on what you want to do. I'm going to find angle N first. So to find the measure of angle N, I'm going to see I got all my options here. So I'm going to go adjacent, hypotenuse in this case. You know what? Let's use tangent here just to show you how that works too. So I want the inverse tangent of angle N, so that means by definition tangent opposite over adjacent. There's my triangle. So opposite is 36. Adjacent is 15. So as I plug these things in, I want the inverse tangent of 36 divided by 15. about a 67-degree angle. So now that I got a 67-degree angle, now what do I do? Well, I sit there and figure out what that is, and that's 90 minus 67. So there's angle N. So the measure of the angle M, and you might have figured it out the other way, that's fine, but if you've got two of the three angles, or one acute angle and a right triangle, just take 90 minus 67, and you got your 23-degree angle. End of story.